have a recording. Okay, so good evening or maybe good morning, depending on where you are, because this is an international dissemination event or webinar of the 3D printing of implants or the Ergo Design Erasmus Plus cooperation building project from Europe. So this is Sabo Gyula, and I'm the coordinator from the professional coordinator from the site. And here in the screen, you can see Dr. Nagy Gabriela, who is the project manager at Óbuda University, and Dr. Hassan Yaber. Dr. Hassan Yaber.
Thank you.
Yeah. So I put some emphasis on this because this is a educational project, but as a lateral effect, we have some PhD degree in this project period. So it's very good, I think, that we have not only the predefined project results delivered, but we have some additional results like PhD degrees, Hassan and Kúnya János, the same, and some scientific publication together with the Bulgarian partner, and so on. So I'm very proud we had some support to make this success. So here we want to share some insight with you
Yes.
about this project, and well, we have 5-6 similar events in English, and we have several national language webinar in these weeks. But since we have similar events in English in Bulgaria and Poland, I think we can give more emphasis to the Óbuda University achievements. So we don't want to present here all the details, but more the e-learning material and our contribution. So to be effective, I ask you to be active. So even though it's online webinar, you can share your questions and insights in the chat box. You can write, or if you are brave enough, maybe you are, you can switch on your camera and open your mic and ask openly. So, but to save some time to our colleagues, I propose to start with Hassan's presentation, and then we have a presentation from the e-learning department, and then I will give a summary. So I think we can start. So Hassan, are you ready?
Yes.
Okay.
Yes, I am ready.
Well, I disappear. I'm here, so my eyes on you, but I disappear because the stage is yours.
Hello.
You can make the presentation. Everything is fine. Please start.
Okay. Can you see my screen?
Yes, we can
Okay.
see your screen. Yeah, the opening screen.
Okay. Thank you. Good morning, everyone, and welcome to my presentation. As you can see in the screen, the presentation is Ergo Design from Concept to Practice. Introduction. The additive manufacturing, another name is 3D printing. According to the ASTM, I mean American Society for Testing and Materials, the 3D printing can be defined as technology or technique of manufacturing three-dimensional objects by addition or by welding or joining the material layer by layer based in the CAD software. This picture shows this technology. As you can see here, this is the first layer, and the product looks like the letter M. Scan by laser, layer by layer, until the final product is complete as shown here. This video shows this technique. Yeah, maybe it is working. Okay. Is the video working, Jula?
There is your presentation, but I think you have this small box. Just hide it. Don't close, but hide on the right side. Move your mouse right.
Okay. Yeah. Okay.
Okay.
As you can see, this is the first layer scanned by laser, and this is the second layer scanned by laser, and the product is tensile test. And this is layer by layer. So this is the technique of 3D printing. Classification of 3D printing. According to the ASTM, 3D printing can be classified to 7 kinds. As you can see here, the first one is wet polymerization, second one material jutting, third one powder bed diffusion, direct energy deposition, binder jetting, material extrusion, sheet lamination. Actually, the raw materials in additive manufacture can be classified based on their form into liquid, powder, and solid. Liquid 3D printing can be classified into wet polymerization and material jutting. In both of them, the UV light can be used to cure or harden the photopolymer resin in wet polymerization or droplets in material jutting. Powder additive manufacturing can be classified into powder bed diffusion, direct energy deposition, and binder jetting. In powder bed diffusion and direct energy deposition, thermal energy like a laser, electron beam, plasma arc is used to melt or fuse the powder material above melting point, and after that the solidification. The difference between powder bed diffusion and direct energy deposition as shown in this picture, just the feeding of the powder. In powder bed diffusion, the feeding like a bed of the powder and scanned by laser, as you can see here. And in direct energy deposition, the powder is deposited through the nozzle or orifice, and at the same time the energy. So the difference between them, between the powder bed diffusion and direct energy deposition, just the feeding of the powder. In binder jetting, liquid is used to join the
Uh-oh. I think Hassan disappeared. Are you with me?
Sorry, the Wi-Fi was not good. Powder additive manufacturing can be classified to powder bed diffusion, direct energy deposition, and binder jetting. In binder jetting, liquid is used to join the powder of material. Solid additive manufacture can be classified to material extrusion, sheet lamination. The most famous solid additive manufacture is material extrusion, where the the raw of material in the form of filament or wire, which is deposited through the nozzle or orifice. An example for this technique is fused deposition modeling. Steps involved in additive manufacture. 3D printing includes a number of steps, starting from the design, means creating of a CAD model. Number 2, convert this CAD model to STL file. Number 3, slice STL file to a thin layer cross section. After that, 3D printing machines. After that, post-processing. Sometimes we have to do post-processing like coating or annealing or oxidization or increased surface roughness or milling. And after that, the final product is ready to use inside the human body. The first step is design. Design includes the main 2 steps. Number 1, collecting the personalized patient data. I mean take CT scan, MRI, X-ray, for example, for the hand of the patient if there is a problem in the hand, or for the leg if there is a problem in the leg. And the second step is the engineer use these data or these images to design a custom implant modeling by CAD software, which is saved as STL file. STL file means creating a niche of tiny triangle placed in the surface by CAD software. And as you can see in this slide, the low resolution STL file, medium resolution STL file, and high resolution. So the STL file is international data interface between the CAD software and the 3D printing machines. 3D printing machines, the most famous 3D printing machines is selective laser melting, SLM, and electron beam melting, EBM, and fused deposition modeling for polymer, FDM. Products or application of 3D printing in biomedical application, as you can see in the screen, like knee joint, hip joint, shoulder joint, finger joint, and dentistry like bridge, screw, artificial tooth, and also cranial. Application of 3D printing in aerospace like Airbus manufacturing, for example, cabin connector, engine liquid oxygen, nacelle hinge bracket, and automotive manufacturing like oil pump, exhaust, water pump. Features of additive manufacturing. Additive manufacturing has potential to produce functionally graded materials. Actually, functionally graded materials, it is a hot subject for the future. So what are the functionally graded materials? As you can see here, the first layer of the functionally graded materials will be 100% from material A, followed by 90% material A, 10% material B, followed by 80% material A, 20% material B, followed until we reach to 100% material B. So the first layer will be 100% from material A, and the final layer will be 100% from material B. So actually it is amazing product for biomedical application. This is the example of functionally graded materials. As you can see here, this 100% from titanium 6 aluminum 4 vanadium alloy. And the top one is 100% from molybdenum. So actually it is a hot subject for future. Also, 3D printing has potential to produce functionally graded structure. As you can see in the top, the density of the porosity is higher than from the bottom. So also it is amazing product for biomedical application. Also, we can combine between functionally graded material and functionally graded structure. So the product can be functionally graded structures and materials. Also, the 3D printing has potential to produce complex structure, as you can see. So the advantage of 3D printing, if you would like to change in the product, just you can go to the CAD software and change and direct print by 3D machine. Not need to use a lot of tools, not to need to use a lot of dies or molds. Motivation to study ergo design course. Implantology. Implantology is a branch of dentistry or surgery. Deals with permanent implantation of artificial tooth inside the jaw or artificial joint implant inside the bone. So, damage of the bone or tooth because of aging, I mean getting older, or because of accident or sports injuries, often requirement to use biometallic implants made from biomaterial to restore this function. So the United Nations in 2013, the United Nations estimated that by 2013, the people aged 60 and over will grow up by 45%. This means the need to use implant biomaterials for surgery will be increased greatly. So imagine that in 2013, over than 4 million people in the USA did total knee joint in the USA. More than 4 million people. Same problem in the Australia. Every year, there are more than 100,000 people need to use knee joint or hip joint implant. Same problem in the European countries and everywhere. So, if you are interested to find a job in the future, I think this course will be amazing for you. Materials used in the implant, like metals like titanium and titanium alloys, tantalum, cobalt chrome alloy, gold alloy, stainless steel alloy. Ceramic, like hydroxyapatite, beta-tricalcium phosphide, alumina, zirconia, and polymers like polyethylene, polyurethane. So these materials used in 3D printing for biomedical application. Engineering factors affecting the success of the implants. Actually, after design and manufacture the implants by 3D printing, we have a lot of challenges to study these engineering factors, like corrosion test, tissue reaction, tissue response, immunity system, mechanical properties, modulus elasticity. So we have a lot of challenges to study the biocompatibility or mechanical properties of this implant after design and 3D printing. Student projects in ergo design, like orthotic device manufacturing and design, like dental bridge. Okay, do you hear me, please? Hello?
Hi, proceed. We are okay. You can continue.
Okay. Student project in ergo design, like cranial implant, also, sorry. I am sorry, I don't know what's the problem. Yes. Like hip and knee implant, also design and manufacturing. After design and manufacturing these products, we have to study the mechanical properties, phase transformation, corrosion test, wear test, and also biocompatibility. Also, spinal fusion cage and elbow joint. Thank you for your attention. And I am so sorry, the Wi-Fi is very bad here.
Okay, no problem, but at least you could join to this event, to this webinar. So it was great to listen you. Hassan, thank you. I'm looking to the chat box. Maybe we have questions. And I want to challenge you together with the colleagues at the e-learning office. So I'm asking you, Hassan, to demonstrate how this knowledge is working in the Ergo Design e-learning course. So I'm asking you to demonstrate topic 14, you know,
Yes.
the integrated exercise. So you will have some help from Aniko. Aniko opened already the e-learning course, so she can go and show, and maybe you can comment how does it work, how we can have hands-on exercise, and how we assess the obtained competencies, the learning outcomes of this course. So Aniko, you can share your screen if you want with an e-learning. And let's see when Aniko is opening the screen. We have a question in the chat box, Hassan. The question that, well, it's, I think, some skepticism in the question from Sophie, but is this real? Is this 3D printing of implants is real for everyday people, or it's science fictions for some regions in Europe? So maybe it's quite expensive and quite technology and labor knowledge intense. So do you think it's available to all, or we need to wait every day? Motivate the people. Hassan, don't run away. What is your answer? You switched off your camera. So, but what you think? Is it real in Hungary or in Europe, or what part we can expect, or when we can expect a real 3D printed denture, for example? When I can afford from my university salary? Hassan.
Yes. Actually, the first step is the design. So we have to identify the problem. What is the problem? So if the problem in the hand, we have to take CT scan for the hand. After that, the design process. After that, what materials is used for this problem? Is the materials used for this problem is polymer or metals? If the polymer it is very easy to use this material inside our college. We can do this project at our college. So if the material used for solve this problem is metals like titanium or cobalt chrome, I think we have to use need Lictorianus cornea to print this implant at Dental Art Technique at the university. So the most important step is what is the problem and what is the material used for solve this problem. Is the materials polymer or the material is titanium or cobalt chrome? So this is very important for each project in Ergo Design.
Oh, I see. So you mean maybe there are simple problems which can be solved soon, but if I have some allergy or something, so maybe I need special materials. And if I have a special case, then I need to wait more.
Actually, after the biocompatibility, this is the the final stage in the test. So the first step is the design, and after that manufacturing, and after that the biocompatibility. So this is the very important. So we can ask the patient if he has any allergic about from the stainless steel or from titanium or cobalt chrome. So there are three metals used in this. I think the stainless steel is more sensitive for each person. So the best one to use now is the titanium alloy. Sometimes the cobalt chrome. So there are a lot of factors to identify or to detect this factor. Yeah.
Okay, I see. I see
Yeah.
your approach, Hassan. Thank you. So maybe together with Aniko, please give some insight how topic 14 is working, how we assess the outcome of this ergo design course. So, what is the content of topic 14? Because in the e-learning material we have an introduction, then 12 separate topics, and then we have an integrating exercise, which is for assessment of the student's learning outcome. So I'm asking, write the learning outcome assessment. What is in topic 14, Hassan? What is in topic 14? Aniko will demonstrate. You can see the screen, and we have this integrating exercise topic. What is here?
Okay, I see.
Okay.
Yes.
Or ladies, you take over. Anyone? Just what is it?
Right. I'll show, and then maybe Hassan can join in. So it's on the week 14, the final exam, and this says the final assignment, integrating exercises. And then you can see what you need to do in order to achieve or pass this course. And it has step-by-step description, what you need to do, how you need to achieve that. Yeah, it's really a thorough explanation what the whole idea behind this ergo design course is. Right. Hassan, would you like to give any more insights on that? It's really a nice summary of the exercise, integrating exercises. Or do you want me to go back to any of the exercise itself, like the last one, wrist joint prosthesis design? Am I not?
Yeah.
Does it
Actually, yeah, okay.
And then it says.
Okay. Actually, the most important step is what is the problem? Is the problem in the tooth or the problem in the hand or there is accident or I don't know what is the problem for the patient. So the first step is what is the problem? Is the problem in the tooth? So we have to manufacture artificial tooth by 3D printing. Okay. So the first step we have to take a CT scan or MRI for the patient, and after that the engineer will use this data to design a custom implant for the patient, and after that the 3D printing. So this is the steps for 3D printing of biomedical application. So the first step, what is the problem? Okay, so after that the design, manufacturing, and after that testing.
Yes, implementation.
Okay. So
cranial implant. Yes. Yeah, every time there's a different, like in case of the previous one said we needed a tooth implant, and then this one is a cranial implant. And also, as Hassan described, what's the problem, and then the steps, what you should do and how you should solve this particular exercise.
Okay, so to the audience, it was a surprise question from my side, so that's why I made some trouble here, because I know that Hassan created this integrated exercise, and it's really guide you or force you to go through the whole design process. So from the problem understanding to the implant delivery and follow-up. So it includes everything, and it's, I think, a very good part in the e-learning material that not only one possible exercise is available to the students, but there are several options from very easy to do. I mean, no special technology and software background required tasks to very sophisticated and technology intense and expensive versions. So with the like with the whole course, the integrated exercise, the final topic, the student learning outcome assessment reflects the diversity of students. So we know that we can have very diverse students with just some interest and very modest technology access to very well situated and maybe already working as dental technician students who can do the most expensive implants as the masterpiece at the end of the course. So I want to demonstrate, and I think all of you can feel that with this course we give hands-on practice. So we have theory and practice balanced. We give several exercises through the course. Every topic has some practical exercise, and at the end we integrate all these pieces of skills into one masterpiece, and we assess the student learning outcome based on the documentation the students prepares from the integrated exercise delivery. So anyway, it was surprise from my side. Sorry to surprise you or sorry to shock you, but I think it's a good opportunity to interact, and I think it's still the final webinar in Hungary in this project, but we still know still learn new things, and we still learn new skills to work together. So I think, Hassan, you are
Yes.
you are done. So no more question to you. Thank you for the presentation. It was really interesting. So I hope the technology will advance faster than my food disappear. So hopefully I can enjoy this technology and
Okay.
not missing any ability to chunk in the future when I have a project like this. So thank you, and
Thank you.
I'm very happy that you continue. And
Okay, thank you.
this stage, I introduce you to the audience that you are the one who is instructing the e-learning course at the CAMOC system, yeah? And you made several updates in the project in the e-learning system together with the ladies. So I saw in the Hungarian version that they made wonderful modifications. So really, I see that all the newest features of the model are there and we are using. So I think it's regarding technology and learning technology and science. This is a really leading edge e-learning course, and we can be proud of it. So, thank you, Hassan.
Thank you.
Can be with us, but we go and move to Aniko presentation. So, please give some information. What is the Obuda University open platform to e-learners, and whether we can have credits from Obuda University if we learn in the Netherlands, for example. So, Aniko, introduce yourself and proceed.
Right. Good morning to everyone. My name is Aniko Nyilas, and here's my colleague Dora Varga. And we are instructional designers and educational content development experts. And we are the ones who have this course to be put on the KMOOC system. And first of all, I would like to give you some overview of what KMOOC is. And I could see there is already a question popping up, saying when will this course actually be available? I'll come back to you later in a moment after this little presentation. Right, so this is going to be a little overview of KMOOC and what it is, what you can find on it, and what you can use it for. So, first of all, what is KMOOC? You can actually log on to KMOOC on this website, so feel free to type that in, look it up, or just scan this QR code in, and it will guide you to this website. So this www.kmooc.uni.obuda.hu will guide you to this website. And KMOOC is actually an acronym, and it stands for this Kárpát-medencei Online Oktatási Centrum, which, if you translate it to English, stands for Carpathian Basin Online Educational Center. And as you can see, there is a bit of a wordplay as well, because MOOC is in it, and with this KMOOC website, we followed the MOOC system, which is the massive open online courses system. So you can access to the courses whenever, I'll come back to the what, mostly whenever and you want, and anybody could access these courses. And Ergo Design is going to be on the, if you click on the English version, the third one, you can't see this right side, but on the left side, and then you just click on Ergo Design, and then you can log on to the course itself. But I'll come back to that question when it is available in a moment. So what is KMOOC? KMOOC was founded in 2014, so it has its 10 years anniversary this year. So now it's kind of well grounded now. So 2014, we had 10 years, and it's kind of well developed. And it is a network of universities. There are 22 Hungarian and 14 cross-border institutions, included like Corvinus University of Budapest, or St. Melville's University, or cross-border ones like Sapientia or Partium University from Transylvania. And these courses, as I said, it adopted the MOOC system. So these courses are free for everyone. And even if you are not a member of a university, you can join it, you can check out all these courses. So I would encourage everybody to have a look around. And if you are a member of the university, it is equivalent to an elective, an optional, or a compulsory subject. and you have a credit transfer option once you finish it successfully. But I'll get back to you in a moment. Then these courses are in English and Hungarian. There are more and more English courses. Mostly they are in Hungarian, but as time progresses, we'll upload loads of more courses, and then check back later, and then maybe there will be some that you fancy. At the moment, there are 55 active courses and more than 30,000 students. And a little bit of a fun fact, a little nugget of some knowledge, like the most popular course is the history of jazz culture. And why choose KMOOC courses? The main reasons are, first of all, you can study anytime, anywhere, even if you are on a bus, a tram, it's available because it's online. And the second main reason could be is that the lecturers are university lecturers, renowned lecturers. It's not like Udemy or Skillshare, where the lecturers could be anyone. Here, they are university lecturers, have the right qualification to teach you that particular subject. You can explore new and exciting topics, whatever you fancy, and if you finish or pass a course successfully, you can request a credit certificate. And then with Ergo Design, it's for three credits. So if you pass it, you can request a credit certificate for those 3 credits. It's completely free, and here comes the part where you can enroll to the courses. It starts at each semester. So this time around, Ergo Design had a longer term of applying, but usually it's the beginning of September, beginning of term, so it's September, or next time it's going to be January, where you can apply for these courses. But only in that case, only in that month, because unfortunately, because it's linked to these credit certificates, so you cannot just apply anytime, because there is this time limit that it had to be finished in that particular term. So that's why you can only apply in the beginning of the term. So January and September, respectively. However, if you, for any reason, did not manage to pass the exam or just didn't have time to finish it all, there are no negative consequences. So you can apply to these courses, and then if you, just as I said, any reason you did not have the chance to finish it off, there's no negative consequence. And if you're not happy with the grade, like you wanted like an excellent mark and you just only achieved a pass mark, then it will only be recorded if you accept it. And you can retake the course anytime. At any time, whenever, yes, you can apply for the exam. For the course, sorry, whenever you can apply for the course itself. Right, and at this point I will give the word to my colleague, Dori.
Thank you. So as you can see, the digital transition moves forward, and the field of higher education cannot stay out of it. So our university, the Óbuda University, tries to respond proactively and also pays attention and invests more resources to the e-learning development. And as a result, our office, the EDTE, our e-learning electronic and digital office, has grown in terms of the number of staffs and besides with professionals with different skills. Which results, you can see on the video montage that we are experimenting with different digital tools such as Articulate, which can be used for e-learning material development or Unreal Engine to make the e-learning contents more enjoyable and using gamification. So you can see we are like building escape rooms or branching scenarios. And thus you can KMOOC can compete with other international MOOC systems. So, and with this, our goal is to develop and actually operate an e-learning courses on the KMOOC, which can be student-centered to reach these goals.
Yes. Yeah. Engaging and interactive and student-centered approach. Yes. Right, and let's see eco-design itself. And then I think then, let's see the website itself. So, does it work? Yes, you have the internet, yeah, good. So, eco-design, as you can see, has 14 topics, and most of them has interactive elements. And this is the part where actually our office came into picture, because we were with collaboration with a teacher, we added some interactive tasks just to make it more engaging. And my favorite is this one, the very first topic. If you log in and enter, there is this, let's make it bigger. No, I'm just looking at the way how to make it even more bigger. Is it like, okay, let's make it in the center. Yes, I can see it. So this is a branching scenario, and then you are put in a scenario where you have to answer certain questions. There is a patient, we have to, well, let's see, what do we need to do? We need to help him to undergo a dental implant procedure. And what to do? Well, let's see, no, that's not the correct answer. That is so, yes, you can go on with these interactive. Yes, I got that right. No, I didn't get that right. Sorry, it did say incorrect. No, that's the right option. Yes, that's the right option. So you can go on.
And you can proceed.
Yeah, and see how this whole process is ongoing. There are some other interactive elements. You can look for it. Like I'm on the left side. Yes, and then you can check out. Here you can. This is the brief sketch, how the skeleton of the course, and this is another interesting element, a timeline, what happened in certain years. If I can get to the next one, the bamboo metal, and then yes, surgical. Ancient Rome, something else was used, gold and silver, and etc., etc. So all these interactive elements, yes,
and it also helps you in chunking the information. So you can also achieve that or find that in a note, but it is like much easier to imagine how it involved this system, this what's that, like
yes,
implants.
Yes, the whole history of implants. And sometimes, not curriculum. I think on the number 4 module, there is sometimes it's embedded within the material and drag and drop. Oh, probably I'm not doing well enough. Oh no, at least which is volumetric. Yeah, found it. So drag and drop exercises that can help you feel a bit more engaged with the material itself. And last but not least, sorry, these are all right. I want to show you our video. So sorry, this is the course itself. The elements in the course, what are these interactive parts, exercises. Two more things I would like to highlight, that the assignments, as Julia also said, they are mostly focused on practical elements, how you would do the, what was that called, the integrating exercise, how you would do those prosthetics. And if you successfully finish the course, then you can get different badges. One is the Master of Implants when you finish all the exercises, and then
that's the maximalist.
Maximalist.
Submit all the written and practical assignments.
Yes, and Master of Implants when you finish the exercises. Sorry, the necessary exercises.
On a high grade, like.
Yes, above 90.
Mm-hmm.
And last but not least, I would like to show you a little bit, I think the shorter version of this video that was taken in a workshop. There was a workshop visit and there was a video taken, recorded of this process, and maybe that will help you oversee the whole procedure. Let me show you a couple of minutes of this, maybe less than a minute. Just starting out with the beginning of the process, needed tooth transplant, and what happens after that. Sorry, I'm going to move it forward. Its way. And with this, thank you for your attention. And if you've got any questions.
Okay, I'm coming back. Thank you, ladies.
Oh,
So
yes, yes. I could already see some questions here coming up. We'll answer in a moment. Like, is there any other language this will actually be available?
So the first question is from Elena. Would you share the website addresses here? So I will put it in the group chat.
Yeah.
And is there any other language course?
Actually, let me just, if you can still see my website, then there are like, this is the website, this KMOOC, Uni, Obuda, etc. And there, these are the English language courses, the Hungarian ones. Here you can use these filters. There are a bit more, but yeah. But there are more coming, definitely. So it's first coming back time and time to check how many more courses there are. At the moment, there are 5, but I can assure you there will be more,
yes.
Loads more.
So actually the original goal was to make e-learning courses in Hungarian, but now we try to open the doors to other languages.
Yeah, exactly.
Okay. Ladies, I want to thank you for this presentation, and not only because it was a good presentation to show what is MOOC and what is there, but it was, I would say, my return from this project. So it was really, really good to see that you enjoy so much. So it was not a presentation, it was a coffee shop meeting of two nice ladies enjoying something together. So I think it was very, very good to see that you find yourself in this project. And I could see this on you on the screen and on the e-learning material too. So it was really, and Hassan too. So he's so devoted. So really, that's what I mean. That this is the lateral effect, which is basically
Thank you.
the objective of this collaboration. So if so at least in my reading, the e-learning or this Erasmus is to build partnerships, and here we made something. So it was really, really good to see you. So thank you. And thank you to Hassan too, that you are doing the
Thank you for everyone. Thank you.
And it's really nice. So I hope you will maintain this course and run this course and really offer this course to students. And if you make a face-to-face meeting in the Obuda University laboratory with some students coming and having a improved blended version of this ergo design course in the sustainability period, then it would be terrific to see how you deliver it. So thank you, ladies. I think no questions right now, but I have, unfortunately, I have something obligatory task here, and still have 20 minutes to show you my presentation. So if you don't mind, I give you some insight what is this project in general. So it will be very, very fast because I only need to present Obuda University task more details. So, and we did, and you can watch other partners' presentations on the whole project. But anyway, ladies, we can change the transmission of the video. You present it to the original video, so we will send the video to the Italian partner, and when they prepare the published version of this webinar, they can change to a better version, not this transmission. Okay, anyway, so what is the ergo design course and why we did it? In a nutshell, really in 10 minutes, what I can tell you about this course. And so here we are. And if you have questions, please, you can ask me too. So this is the improving digital skills for ergonomics and bioengineering innovation for inclusive healthcare. The keywords there, inclusive healthcare and digital skills and bioengineering together. And ergonomics here is to reflect that this is a human-centered approach, and we want to make the life more human-oriented. So from Obuda side, we have a long history here. So we have an international mobility network in the CEPUS in the Danube region in Europe for ergonomics and human factors. And here we have some partners. Actually, today we have 10 university partners in the CEPUS network, and that was the foundation of this project, because we come together in this CEPUS network and decided to change and go 2 level up. And I'm Erasmus project, and then we succeeded with 2 projects actually. So the Life in the AI Era HEDI project, and with this Ergo Design, we started both projects together 3 years ago. We finished the HEDI project 5 years ago, and I can tell you that that is best practice in the Erasmus platform. So it was a very, 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 very good project. And we are going to finish this Ergo Design course in 3 weeks. Okay, so this is the objective, which is reflecting to the European objectives in the actual project period. So the basic data, total grant 320,000 euros for 3 years for 6 partners. So it's really the budget we can use to make our dreams true. So it's not to be a millionaire, but to make what we need. And from this money, we could meet each other several times in the project. We could travel to village and make videos. We could offer pilots to students and so on. So it was budget to cover our expenses. Okay, and 36 months. And here you can see the official website, the ergodesigner.eu, the project website, and the collaborative platform created by the project at Varna University, Bulgaria. But what our colleagues presented is the KMOC, is on the Obuda University platform, but this is more than the project results. It's already the sustaining of the project results, because we closed the development of the e-learning material mid-24. So this is an updated, improved version where we made several modifications to fit more to the Hungarian needs. Okay, so it's already the sustaining period, what we can see in the Obuda site. Okay, project partners, Athens University, Poznan University, Košice University, Varna University of Technologies, and Obuda University, Budapest. We had several roles and one partners to provide project management background. Okay, we had 5 projects, like always in Erasmus project. We have project results according to the number of the partner universities. So we had a dynamic toolkit. We had e-learning or material curriculum development. We had a collaborative platform. we had e-learning material, and we produced a guide to reproduce the ergo design-like courses. So in very short, what are they? First is the dynamic toolkit. This is a collection and description of several tools used to 3D print implants. So from the picture or model capturing to the design and printing, several tools are collected and selected thoroughly, and we have a tool where you can choose what kind of tools you want to use. So you can indicate what platform are you using, you can indicate what function do you need, and it's very important that you can filter out lessons what you have or what you need, because we target several target groups, and we expect some students from the field who are already printing implants, may be employed by a laboratory, as we can see in the video, or we can have absolutely beginners without any background who wants to make the course free of charge without any special and payable softwares. So it's very broad tool assortment what you can see here and filter out what you need. Okay, the next is the collaborative platform, which is basically a model system. And you can see that in Obuda University, we have a very nice CAMOC system or model system, but it's not general. So there are other universities where they still need to improve. And in this project, we collaborated with Varna University, and we gave them the first impulse to establish an e-learning platform with Moodle. So it's a new platform to them, and they created some basic features which allowed us to create the ergo design course, but we have a better one, and then we use in the sustaining period our platform. But it's okay, we agreed with the partner in this way. But it's a big improvement and big benefit to the community to create this competency in Bulgaria. Okay, so this is the collaborative platform. Then the curriculum design, it was a huge task, and we made a template to describe different modules, and we had a technology. We used Delphi methodology to identify skills and skills, competency factors, and competency levels in the course, and we created a structure where we describe the topics. So, for example, here you can see that we created the card for all the topics with the title, with the content, with the outcomes, with the methodology, with the duration, with the ECTS, and the way or how we learn. And here we have some information about the Delphi methodology. So it really presents the detailed way we identified the need and the content of this e-learning course. So maybe you are familiar with the Delphi methodology. It's not so easy, but it's a very good methodology to collect experts' opinions and somehow reach a consensus of experts. So on the right side, you can see the flow of the Delphi methodology. And the result is the lecture or the course description. You can see that we decided to have 14 topics because we have 14 weeks in the university usually. So in an academic semester, we have 14 weeks. So we created this university learning course accordingly. And you can see that we split the job between partners, and every partner knew what topic to develop. So it was again a big challenge to communicate and harmonize different learning material creation methods. So we have different ways to create e-learning material from Košice or from Athens, and they have different style learning material. So when we discussed what should be in specific topics, we had big arguments sometimes or long discussions to understand each other's learning material development methodologies. And well, we had to make several changes, and it was an iterative process later to create all these materials. But you can see that on the left side we had theory and right side practice. So we wanted to have theory and practice balanced in the course. And you could see already from the presentation of the topic 14 that we had practical exercises through the course, and we come back at the end and the final assessment. We ask students to use all these skills they acquired through the course. So I think it's a very, very, very well structured course and with lots of hands-on exercises. Okay, next is the building of the e-learning course. So it was a long story with lots of delays, took more than a year. But at the end, we had a course, and we had a pilot course with 200 students, with lots of feedbacks, lots of assessments, and final assessments and interview of students and teachers and everyone else. So it was a very long story, but I can tell you that lots of students reached the end of the course and had the credits at the end, and we had lots of feedbacks, and these feedbacks allowed us to improve it, and we made lots of corrections in the Bulgarian site, and improved and finalized the project results there, and then moved the e-learning material to Óbuda University and started the next round and the sustaining period, and we have an even better course in KMOOC with several students and with a very devoted instruction, Hassan. Okay, and the next is the handbook, and I want to draw your attention that we have a handbook to you to redo this ergo design course. So I hope you enjoyed this webinar, and you can see that we have lots of fun and lots of results together. So and good working conditions and some mobilities and some interactions and so on. So we collected everything you need to redo this project. So we have a guidebook, and this guidebook is available in several languages. We will publish the Hungarian version in the next week. So we present here the topics and the structure of the course and how we do it, what is the background of the didactic, and how you define the competencies and so on. So we have a handbook. If you want more details in English, please ask the Slovakian partner and look at the presentation of the Slovakian partner webinar. So we have very nice project results. We have an operational e-learning course. We have a collaborative platform. We have the toolbox, and we have the guidebook here. So, of course, we do for the broader public. So we have all these courses available for free. You can enroll the KMOOC for free, of course. We have some face-to-face events. We had a final conference. We have this webinar, and we made this webinar also in Hungarian. And we will close the project next Monday in Poznan when we meet with all the project partners. Effect is measurable. We had everything done. We have everything verified, not only done, but verified. So we had validation process, we had quality assurance, everything is good. And where we had lots of lateral effects, like good minutes, like PhD degrees, like Q1, Q2 level publication from this project and so on. So it's very good. And we achieved what was my personal objective with this project. We established very good connections in universities and between universities and with partners too. So it was a very good possibility for networking. And I absolutely convinced that we are improved with KMOOC. And this project contributed a lot to the KMOOC office development. So with this HADI and Ergo Design project, we gave lots of freedom and possibility to test and implement new modeling plugins, and we can try lots of new possibilities to learn, and we could adopt this technology in the learning material development. So I think it was very good, and I think with the collaboration with other universities, we really established possibilities for new collaborations and new projects. So I'm happy with the results. So needless to say that I'm happy that we are finishing this project in the next week, because it was a long one and with lots of problems. But now I want to look at the positive side. And thank you, a big thank you to all of you. On the left side, there are the representatives of the project partners, so that's why I'm on the left side. And Beata Nugaska, the coordinator of the project, on the top from Poznan University. And on the right and the middle column, there are the Hungarian team names. And really, thank you to come with me in this challenge. And it was very nice. And it's very good to have you here. And I hope the assessment will score up good. And I hope we can work together on other projects, and we'll continue. So thank you, guys. And at the closing slides, I have the websites of the partner universities. And the very last slide is the QR code for the KMOOC Ergo Design. So please go and try and use. So here we are at the end of this webinar. Thank you for coming. Thank you to my colleagues to organize the webinar. Thank you, Edina. I know that you are in the background, and you try to moderate the discussion in the background. Thank you to come Hassan and ladies in the office. And maybe I give over to Gabriela. Maybe if you are here and you spend all your morning and in reality all your life with this project, so what you can
Dear Julia, thank you so much for this fantastic project. It was a pleasure, a really pleasure to watching all your work and enjoying that more than interesting topic to be so deeply involved and elaborated. Thank you so much for all the team for the encouragement and enthusiasm how they are all worked over this project. Thank you so much. Thank you.
Here we are at the end, almost at the end of the project. We will make public this recording. The Italian partner will make some editings. I think the technical break will be cut out, I guess, and we change the original video to the transmission from the mod office. But anyway, I think it was good to be with you. And to be honest, it was good to go through all these projects again. So it was a 3-year journey, and here we could see what happened. And I must tell you that I saw some new still. So I thought that I knew everything, but today I saw something new, and that was because our colleagues didn't stop to work in this project, but they still are continuing and developing this course, and they are improving the MOOC system with eco-design. Okay, it's hard to stop and finish something, but it's time. So thank you, goodbye, and have a nice day.